Hello everyone. Welcome to Let's Crack UPSC CSE English. In our today's session, we will continue with our marathon session on fundamentals of physical geography. Dear friends, in our previous session, we have discussed about the composition and structure of atmosphere, where we have studied about composition of the atmosphere, then gases, water vapor, dust particles, and then in detail structure of the atmosphere. Then dear friends, we have also discussed about troposphere, tropopause, then stratosphere, stratopause, mesosphere, mesopause, thermosphere and exosphere. If you remember, we have discussed all these layers of temperature conditions in detail. Now, so friends, the troposphere is the lowermost layer of the atmosphere and its average height is 13 km and extends roughly to height of 8 km near the poles and about 18 km at the equator. After troposphere, we have discussed about the tropopause. So the zone which separating the troposphere from stratosphere is known as tropopause, this one, and the air temperature at the tropopause is about minus 80 degrees over the equator and about minus 45 degrees over the poles. So we can say the temperature here is nearly constant and hence it is called tropopause. Then we have discussed about stratosphere, which is found above the tropopause and extends up to the height of 50 kilometers. Then we also discuss about the one important feature of the stratosphere is that it contains the ozone layer, and this layer absorbs ultraviolet radiation and shields life on the earth from intense harmful form of energy. Then mesosphere, which lies above the stratosphere and which extends up to the height of 80 km. Then in this layer, once again temperature starts decreasing with the increase in altitude and reaches up to minus 100 degrees Celsius at the height of 80 km. Now, the upper limit of mesosphere is known as mesopause, and the ionosphere is located between 80 and 400 km above the mesopause. So it contains electrically charged particles known as ions, and hence it is known as ionosphere. Then, with the structure of temperature, we have also discussed about elements of weather and climate, then solar radiation and heat balance and temperature, where we have studied about solar radiation, variability of insolation at the surface of the earth, then heating and cooling of atmosphere. Now, let's start with the discussion. Terrestrial radiation. Before that, dear friends, it's my pleasure to welcome you all on Unacademy, India's largest learning platform. As you know, UPSC has announced Civil Services 2020 results recently. So congratulations to all successful candidates, including Unacademy learner Jagrati Avasti, who secured All India second rank. Dear friends, there are 169 Unacademy learners have cracked the UPSC CSE 2020, and still we are counting the numbers of successful candidates. Now friends, it's me Rushikesh Inamdar, guiding UPSC aspirants from last 8 years. You can follow me on Unacademy through this link, or just go through the Unacademy app, in search tab find out my name and follow my profile to get important update about our and schedule of our upcoming free special classes. Friends, do not forget to join our Telegram group, where you will get important updates related civil services preparation. If you have any queries related to your preparation, you can ask over through Telegram group. Unacademy Combat we are conducting on every Sunday morning 11 am. So there will be 56 questions you have to solve in 60 minutes, and as per your ranks you will get amazing prizes and scholarships. So you can use the link to register for the combat, and also you can use invite code RBL Live to register for the UPSC combat. Now friends, we are also providing study material, that is 20 books in hard copy, free with 1 year and above subscription. Along with that, those aspirants facing financial constraint, they can go with the no cost EMI or loan facilities. The link is provided in the description box, and also you will avail 10% discount using code RBI Life. Dear friends, there are Plus and Iconic paid subscriptions on our platform. In Plus subscription, you will get live classes, structured courses, unlimited access for live and recorded classes along with weekly test. And in Iconic subscription, you'll get additional features with Plus subscription like personal guidance, study planner, study material, experts guidelines, and test analysis. Now, you can also avail 10% discount using referral code RBI Live. Yes, the 10% referral code discount you will get, which means for the 1 year of Plus subscription you have to pay 44,550 rupees, and for the 1 year of Iconic subscription you have to pay 67,050 rupees only. The discount is also applicable on optional subscription using referral code. And friends, do not forget to join our free test series. So you can use code RBI Live to unlock the test. Now, friends, let's start with the terrestrial radiation. Yes. Now friends, understand the insolation which received by the earth insolation received by the earth in short waves. Yes, short waves forms and heats up its surface. Now friends, the earth, after being heated itself, becomes a radiating body, and it radiates energy to the atmosphere in long wave form. Now this energy heats up the atmosphere from below. So this process is known as terrestrial radiation. So the earth, after being heated, itself becomes a radiating body, and it radiates energy to the atmosphere in long wave form. So this energy heats up atmosphere from below, and this process is known as terrestrial radiation. Now, the long wave radiation is absorbed by the atmospheric gases, particularly by carbon dioxide and other greenhouse gases. Thus, the atmosphere is indirectly heated by the Earth's radiation. Now, the atmosphere in turn radiates and transmits heat to the space. Finally, the amount of heat which received from the sun is turned to space, and thereby maintaining constant temperature at the Earth's surface and in the atmosphere. So the atmosphere in turn radiates the transmits heat to the space, and finally the amount of heat which received from the sun is turned to space, thereby maintaining constant temperature at the Earth's surface and in the atmosphere. Now then, heat budget of the planet Earth. Let's discuss about the heat budget of the planet Earth. Now friends, see the figure 9.2, which depicts the heat budget of the planet Earth. The Earth as whole does not accumulate or lose heat. It maintains its temperature, and this can happen only if the amount of heat received in the form of isolation and equals the amount lost by the Earth through terrestrial radiation. Now consider that the isolation received at the top of the atmosphere is 100%, and while passing through the atmosphere where some amount of energy is reflected, scattered and absorbed. So only the remaining part of reaches the Earth's surface. So roughly 35 units are reflected back to the space even before reaching the Earth's surface. Now of these, 27 units are reflected back from the top of the clouds and 2 units from the snow and ice covered areas of the Earth. The reflected amount of radiation is called albedo of the Earth. Yes. Now, when we consider that the insolation received at the top of the atmosphere is 100%, while passing through the atmosphere, some amount of energy is reflected, scattered and absorbed, only the remaining part reaches the Earth's surface, and roughly 35 units are reflected back to space even before reaching the Earth's surface. So friends, where these 27 units are reflected back from the top of the clouds and 2 units from the snow and also the ice covered areas of the Earth. So the reflected amount of radiation is called as albedo of the Earth. Now, the remaining 65 unit, yes, see the reflected by space. See, this diagram will understand the complete concept. Now, the remaining 65 units are absorbed, where 14 units absorbed by atmosphere, 51 units by the Earth's surface, and the Earth radiates back 51 units in the form of terrestrial radiation. So of these, 17 units are radiated. Yes, this 17 units radiated to space directly, and the remaining 34 units which are absorbed by the atmosphere, where 6 units absorbed directly by atmosphere, and 9 units through convection and turbulence, and 19 units through latent heat of condensation. Then 48 units absorbed by atmosphere, where 48 units from insolation and 34 insolation and plus 34 units from terrestrial radiation. So basically 48 units absorbed by the atmosphere are also radiated back into the space. So the total radiation returning from the Earth and the atmosphere respectively, 70 plus 48 is equal to 65 units. So 65 units, which balance the total 65 units received from the sun. Now this is termed the heat budget or heat balance of the Earth. Now this explains why the Earth neither warms up nor cools down despite the huge transfer of heat that takes place. Now so basically overall this explains why the Earth neither warms up nor cools down despite the huge transfer of heat that takes place. Now after that we will discuss about the variation in the net heat budget at the Earth's surface. the variation in the net heat budget at the Earth's surface now. As we have discussed earlier, there are variations in the amount of radiation which received at the Earth's surface so some part of the Earth has surplus radiation now. Excuse me. So some part of the Earth has surplus radiation balance while the other part has deficit now. See the diagram which depicts the latitudinal variation in the net radiation balance of the Earth. So the atmosphere, in the atmosphere system. So this figure which shows that there is a surplus of net radiation balance between 40 degrees north yes and south 40 degrees north and south, and the regions near the poles have a deficit. Now the surplus heat energy from the tropics is redistributed redistributed polewards, and As a result, the tropics do not get progressively heated up due to the accumulation of excess heat, or the high latitudes get permanently frozen due to excess deficit. Now, here is a latitudinal variation in the net radiation balance. So, this is solar radiation and this one is terrestrial radiation. Now, there is a surplus of net radiation balance between 40 degrees north and south, and the regions near the poles have a deficit. The surplus heat energy from the tropics do not get progressively heated up due to the accumulation of excess heat, or the high latitudes get permanently frozen due to excess deficit. Now, let's discuss about the temperature. Now, the temperature where the interaction of insolation with the atmosphere and the Earth's surface, which creates heat with heat, is measured in terms of temperature. Now, the interaction of insolation with the atmosphere and the Earth's surface, which creates heat, which is measured in terms of temperature. Now, while heat represents the molecular movement, while heat represents the molecular movement of particles which comprising a substance, so the temperature is the measurement in degree of how hot or cold a thing or a place is. Now, there are factors Now, the factors controlling temperature distribution So let's discuss about the factors controlling temperature distribution. Now friends, the temperature of the air at any place is influenced by the latitude of the place, then altitude of the place, then the air mass circulation, presence of warm and cold ocean currents, and then local aspects. So basically the temperature of air at any place is influenced by all these factors: latitude of the place, altitude of the place, distance from the sea, that is the air mass circulation, presence of warm and cold ocean currents, and local aspects. Now, next is the latitude. So let's discuss about the latitude in detail. Now friends, the temperature of a place which depends on the insolation received. So it has been explained earlier that the insolation varies according to the latitude. Hence the temperature also varies accordingly. After that, altitude, the atmosphere is indirectly heated by atmosphere is indirectly heated by terrestrial radiation from below. Now, therefore, the places near the sea level record higher temperature than the places situated at higher elevations. Now, in other words, the temperature generally decreases with increasing height, and the rate of decrease of temperature with height is termed as the normal lapse rate. So it is 6.5 degrees Celsius per 1000 meter. Now, there should be discussed distance from the sea. Now, another factor that influences the temperature is the location of place with respect to the sea and compared to the land. So the sea gets heated slowly and loses heat slowly. So normally sea gets heated slowly and loses heat slowly. So land heats up and cools down quickly. So the land which heats up and heats down quickly. So therefore, the variation in temperature over the sea is less compared to the land. The places situated near the sea which come under the moderating influence of the sea, and the land breezes which moderate the temperature. Now here we should also discuss about the air mass and ocean currents. Now, like the land and sea breezes, the passage of air masses also affects the temperature. And the places which come under the influence of warm air masses experience higher temperature, and the places that come under the influence of cold air masses experience low temperature. And similarly, the places located on the coast where the warm ocean currents flow record higher temperature than the places located on the coast where the cold currents flow. So this is the air mass and ocean currents. After that, we will discuss about the distribution of temperature. So let's discuss about the distribution of temperature. I'm audible to you all. There is, yes friends. Now distribution of temperature. Distribution of temperature. The global distribution of temperature can well be understood by studying the temperature distribution in January and July. Now, the temperature distribution is generally shown on the map with the help of isotherms. So basically, the isotherms are lines joining places having equal temperature. Now see the diagram which is showing the distribution of surface air temperature in the month of January. So these both figures which show the distribution of surface air temperature in the month of January and July. Now in the general effect of latitude on temperature is well pronounced on map, as the isotherms are generally parallel to the generally parallel to the latitude. So the isotherms which are generally parallel to the latitude, and the deviation from this general trend is more pronounced in January than in July. Now, especially in northern hemisphere, where this deviation from January deviation from in this general trend is more pronounced in January than July. Now friends, northern hemisphere the land surface So the land surface area is much larger than in the southern hemisphere. So hence, the effect of landmass and the ocean currents are well pronounced. Now, so hence the effect of landmass and ocean currents are well pronounced. Now in the January, where isotherm deviate to the north over the ocean and the south over the continent, and this can be on the North Atlantic Ocean. The presence of warm ocean currents, Gulf Stream and North Atlantic drift make the Northern Atlantic Ocean warmer and the isotherms bend towards the north. So over the land, the temperature over the land, the temperature decreases sharply and the isotherms bend towards south in Europe. So over the land, the temperature decreases sharply and the isotherms bend towards the south in Europe. Now, see, it is much pronounced in the Siberian plain. The mean January temperature along 60 degrees east longitude is minus 20 degrees Celsius, both at 80 degrees north and 50 degrees north latitudes. The mean monthly temperature for January is over 70 degrees Celsius. In equatorial ocean, over yes. So the mean monthly temperature for January is over 27 degrees Celsius and in equatorial oceans over 24 degrees Celsius. In tropics and 2 degrees Celsius to minus 0 degrees Celsius in the middle latitudes and minus 18 degrees Celsius to minus 48 degrees Celsius in Eurasian continental interior. Now, the effect of the ocean is well pronounced in southern hemisphere, and here the isotherms are more or less parallel to the latitudes, and the variation in temperature is more gradual than in northern hemisphere. The isotherm of 20 degrees Celsius, 10 degrees Celsius and 0 degrees Celsius, which runs parallel to 35 degrees south, 45 degrees south and 60 degrees south latitudes respectively. Now, in July, the isotherms generally run parallel to the latitude and the equatorial oceans record warmer temperature more than 27 degrees Celsius. Now over the land, more than 30 degrees Celsius is noticed in subtropical continental region of Asia along the 30 degrees north latitude. Now friends, along the 40 degrees north, which runs the isotherm of 10 degrees Celsius and along the 40 degree south. So the temperature is 10 degrees Celsius. Where, see the picture which shows the range of temperature between January and July. The highest range of temperature is more than 60 degrees Celsius over the northeastern part of Eurasian continent, and this is due to continentality, and the least range of temperature 3 degrees Celsius, which is found between 20 degrees south and 15 degrees north. Now, after this we will discuss the inversion of temperature. Before that, just go through these range of temperature between January and July, the distribution of surface air temperature in month of July, so let's discuss about the inversion of temperature. Now friends, normally temperature decreases with increase in elevation so it is called normal lapse rate. Now, so at times the situation is reversed and the normal lapse rate is inverted. So it is called inversion of temperature. So inversion is usually of short duration but quite common nonetheless. So normally a long winter night with clear skies and still air is ideal situation for the inversion. So the heat of the day is radiated off during the night, and by early morning hours the earth is cooler than the air above. Now over polar areas temperature inversion is normal throughout the year. Now, see once again the inversion of temperature. So temperature decreases with increase in elevation. It is called normal lapse rate. So at times the situations is reversed and the normal lapse rate is inverted. It is called inversion of temperature. Now the inversion is usually for short duration but quite common nonetheless. So long winter night with clear skies and still air is ideal situation. Air is ideal situation for inversion. The heat of the day is radiated off during the night, and by early mornings, yes, early morning hours, the earth is cooler than the air above, which is over polar areas. So temperature inversion is normal throughout the year. Now let's see the surface inversion promotes stability surface inversion which promotes stability in the lower layers of the atmosphere. Now smoke and dust particles get collected beneath the inversion layer and sprayed horizontally to fill the lower strata of atmosphere. Dense fogs in mornings are common occurrences, especially during winter season. Now this inversion commonly lasts for few hours until the sun comes and being to warm the earth. Now the inversion which takes place in hills and mountains due to air drainage. Now, cold air at the hills and mountains produced during night, which flows under the influence of gravity, now being heavy and dense, the cold air which acts almost like water and moves down the slope to pile up deeply pockets and valley bottoms with warm air above. Now this is also known as air drainage. Now it protects plants from frost damages. So here see, Planck's law, which states that hotter a body, the more energy it will radiate and the shorter the wavelength of the radiation. Now, when we are talking about specific heat, is the energy needed to raise the temperature of 1 gram of substance by 1 Celsius. Now, the Planck's law, which states that the hotter a body, the more energy it will radiate, and shorter the wavelength of that radiation. So specific heat is the energy needed to raise the temperature of 1 gram of substance by 1 Celsius. Now, in next chapter we will discuss about atmospheric circulation and weather systems. Now, we have discussed about the solar radiation, heat balance and temperature, where we have covered the solar radiation. So friends, the Earth's surface, which receives most of its energy in short wavelengths. So the energy received by the Earth is known as incoming solar radiation. In short, we are termed it as insolation. Then we have discussed about variability of insolation at surface of the Earth. Then the passage of solar radiation through the atmosphere. Then heating and cooling of atmosphere. Today we have discussed about terrestrial radiation, heat budget of the planet. That is, we have discussed this heat budget of the Earth. Then variation in the net heat budget at the Earth's surface we have discussed. The latitudinal variation in net radiation balance. Then temperature, then factor controlling temperature distribution, latitude, altitude, distance from the sea, air mass and ocean currents, and then distribution of temperature. And then we have discussed about the inversion of temperature, Planck's law, and the surface heat is the energy needed to rate the temperature of 1 gram of substance by 1 Celsius. So friends, that's it for today's session. Now do not forget to join our new batches from 29th September. There are 1 year and 2 year batches. And from 18th October, we are going to start answer writing program and quality enhancement batch. So as per your convenience, you can join these batches. Yes. So friends, you can also attend weekend current affairs simplified batch, which will help you to cover complete general studies. So we will cover the current affairs from major sources like newspapers Hindu, Indian Express, magazines like Yojana Kurukshetra Down to Earth, EPW, and the other important government sources like PIB, Rajya Sabha TV, and All India Radio, where we will provide you monthly current affairs magazine also. Do not forget to enroll yourself for UPSC Combat using invite code RBI Live, and for the registration of Combat, the link is provided in the description box. So every Sunday morning 11 AM we are conducting UPSC Combat. So there will be 56 questions and 60 minutes time allocated for that. So friends, as per your rank, you will get amazing prizes and scholarships. Like first 3 rank holders will get 1 year UPSC CSE plus subscription. Along with that, other rank holders will get 75%, 50% and 25% subscription. Sorry, discount on subscription, which means you will get scholarship. You will get study material in hard copy. Right. So the study material worth rupees 10,000 you will get absolutely free with 1 year subscription and above. No cost EMI or loan facilities available. The link is provided in the description box. And you can also use code RBI Live to get 10% discount. Now, you can chase your UPSC dream with Unacademy. Yes, the practice makes perfect. So friends, practice the multiple choice questions. And we are providing the complete test series. Yes, test series for complete general studies. So join this free test series. You can use code RBI Live to unlock the test. And once again, congratulations to all successful candidates who have cleared UPSC CSE 2020. Here is the Jagriti Avasti, Unacademy learner cracked the UPSC CSE 2020 with All India second rank. And there are 169 plus learners cracked UPSC CSE, and we are still counting the numbers. So friends, you can continue or you can start your preparation with Unacademy to achieve your goal into the UPSC CSE examination. So in the next marathon series, we will continue the remaining topics. Till the time, keep studying, keep revising. Do not forget to like, share and subscribe Unacademy videos. Stay home, stay safe, get vaccinated.